I'm Nick Hartwell from Festo, and in partnership with RS, I'm going to walk you through on connecting and configuring a pneumatic system with a programmable logic controller. Here we have our pneumatic components, which also contains some input and output modules, IO-link modules, and also we're controlling it via a Siemens PLC. This allows us to distribute the signals and actuation around the machine and get all the data back into our system. Initially we'll use some commissioning software once everything's connected to parameterize and just do a quick functional check of the items. So we'll do that now. So we'll start by looking at the physical connections between the PLC and our pneumatic components. So the green cable initially is the Profinet communication from the Siemens PLC, and then this communication cable will then feed into our proprietary system and then carry those signals back through the data channels, the input blocks, the output blocks, and then we can get that control back to our PLC and analyse that data. So on the rig here we have a pneumatic cylinder. From this cylinder we have the pneumatic tubes. These tubes are feeding into our valve terminal, and then by controlling this valve terminal we can actuate the cylinder. Now with everything connected, we're ready to move on to the software configuration. So before we interface with the PLC, let's do a preliminary check using our commissioning software, in this example Festo Automation Suite, just to ensure everything's functioning and correct. So now we have our system powered up. We can now use the commissioning software, in this instance Festo Automation Suite, to import the data into the topology here and actually do a preliminary check on the pneumatic valve terminals themselves. So I'll do that now. So we're going to scan with the magnifying glass for the devices. We're going to open the network branch, and we can see these items here correspond to how we have on the system here. So we'll add these to the project with this button here, import the topology, and then this brings it, if we go to the house screen at the top, this brings it into here. Okay, so everything we see here is what's on the board in front of you. So I'll just move these items across so we can see everything together. So for the preliminary checks, we're just going to connect to a valve terminal. So we're going to connect to this one on the top here, just to ensure the valves are switching themselves on there. So we'll open up the valve terminal itself. This is just initializing the plugin, just doing all the checks on the system, and then we're going to connect to it at the top here. So establishing connection, it's reading the parameters from the device. We can read from the device, and we're now connected at the top here. So in order to check the communication, the valves are switching, we can go to the process data on here, and then we can look on here at the prepared values and change these to true, and what we're looking for is the valves to give us a visual orange indicator that they're switching. So now we're going to switch the valves using this prepared value column. Okay, so we're going to turn these to true, and what we're looking for is a visual indicator on the valves that they're switching. So we'll make these first four true, we'll write the data, and then on the camera you'll see the first two valves are indicating as functioning. So now we have the communication working in our commissioning software. We're now going to go into the third-party software, which will be Siemens TIA Portal, to now show this configuration within that program. So within the Siemens TIA Portal program, if we look at our devices and networks, we have our PLC here, and I've imported the main master module into the system. If I go into the system, we can see all the devices on the right hand side here. So these devices I've parameterized, so I've used the hardware catalog, and I've dragged these devices into the system in the order that we see in Automation Suite. So what we see here from before, we're now seeing this in this system here. You can scan the network to import these devices, and that's done through the online tab, hardware detection, Profinet devices from the network, and then this goes and scans the Profinet network and can find those devices on the system. So if we do a search, just searching on the Profinet network, looking for any Profinet devices that are connected. So it's found this device here, so again this would be imported into the system. So now we have these devices in the system. We can see we have some valves. We have an IO-Link master with some devices attached, and we have an 8 digital input module. So these are the modules that are on the system in front of us here. So the pneumatic cylinder is attached to this second bank of valves here, and these valves have a physical address. So within TIA Portal and programming software, you have an address for the valves. So in this instance, it's the output address number 1. So in order to get these valves switching and functioning within the third-party software, we first need to download the parameterization into the PLC. So we click on the PLC, we click on the download to device icon at the top, and this is then just going to download the current project into the system. So we select our interface, we select my network port, and we start a search. So it's found our PLC on the system. That's going to populate that here in a second, and then we can click on load. And that's going to load all the parameters into the system, so it's ready for loading. Just checking there's no errors in the system or in anything we've parameterized, and then we click on load. And then we click on finish, and then we can now go online to the system. So we click go online, and as you can see on the left hand side and the right hand side, everything is green and healthy. So we mentioned earlier on that the valves are attached to, the cylinder with the valves is attached to this bank here with address number 1. So in order to show the cylinder working, we need to actually give these addresses to the system in there. So we can go to our watch table and we can parameterize our addresses in there. So we said the first address was 1, it's an output address. So I can put Q1.0, and then I can add another selection here. So I've got 8 addresses, so I can add 7 rows. So these are the individual addresses for the valves. So if I go online with the binoculars, I can now switch these valves in order to switch the pneumatic cylinder. So shortcut Control F2, cylinder goes out, Control F3 turns it off, and if I select the next valve down, that will send the cylinder back, and vice versa. So this is showing the cylinder working in the third-party software, and then you would then go on to then make your program. If you had multiple cylinders on the system, other devices that were controlled by the input blocks, output blocks, IO-Link devices, and then they would all be addressed in a similar fashion. So now we have our connections there. It's important to talk about diagnosis. From a diagnosis perspective, both the commissioning software, in this example Festo Automation Suite, and the PLC can fully diagnose the system. Generally the system, if it's green and it's running healthy, then it'll be absolutely fine. But it may be a case of that a wire has come loose, or one of the devices is not functioning correctly, the power may have been lost. But these faults can be easily identified with the commissioning software, in this example Festo Automation Suite, or via the PLC controller itself. So this concludes our commissioning and integration with the pneumatic systems and the IO-Link blocks and the input and output blocks. And as you can see, using a couple of pieces of software, we managed to do our preliminary checks, and then we've moved over to our third-party PLC environment to actually get function from the system. So check out some of our other videos in the series, including how to troubleshoot your pneumatic systems. And don't forget to like and subscribe for more practical engineering videos.